Is everybody on page 293 in their workbooks? Okay. So on this topic, there are some that we skip again. So, I'll tell you which ones we're going to skip. All right, so first, right here, does anybody know what this is? Y'all don't know what that picture is? Okay, I was about to say, I know y'all ain't, I know I ain't that old, and y'all ain't that young. All right, so a grandfather clock, how does it run? What does it use? It uses weight, okay? So the pendulum at the bottom is what swings back and forth, and as the wheel turns, what moves? The hands on the clock, okay? So the first question on here shows us the pendulum moving. So when it's 10 centimeters, how fast is it moving? 0.6. When it's 20 centimeters, it's moving 0.9. When it's 30, it is how many seconds? 1.1. When it's 40, it is 1.3. Do you see a pattern? $50 goes up 1.4. And 6 it's going up 0.3. From 0.9 to 1.1, it's going up 0.2. 1.1 to 1.3, it's going up 0.2. 0.3 to 0.4 is 0.1. 0.4 to 0.6 is. So, is there a pattern? No, there's no pattern. So, on your paper, to the right of the chart, I want you to plot the points. My x-axis is my length, and my y-axis is my seconds. All right, number 2 asks, once you get that done, trace your line, trace your dots. Question 2 says, consider your toolbox of parent functions: linear, quadratic, logarithm, exponential, and square root. Which are likely candidates to match the data? Well, which one can you automatically just completely knock out? Linear. Why? It is not a straight line. So we know it is not linear. Down here in the yellow, it says it appears to show an increasing function that turns downward. Okay? So, what does number 2, just write your choices, just what it could be. So it could be it's not linear, but it might be quadratic, might be half of a quadratic. What about a log? What's a log look like? We remember? Let's go to number 3 and write them. Number 3, we have a quadratic it could be. Now, what do you know about that graph on your paper? Are my ends pointing up or my ends pointing down? My ends. They're pointing down, right? Okay, so quadratic may look like this. A square root, what does it look like? It's on your face. An eyebrow. A log. If we have a graph, it's going to look something like this. And an exponential is what kind of sign? It's a brand. A Nike sign. So, based on those 3 graphs that we have drew on number 3, what kind of function is the pendulum showing on number 1? Is that a quadratic function? So it look like an upside down. Is it upside down U and N? No. Is it like an eyebrow maybe? Yeah, maybe. What about a log? What is the difference? Look at your graphs. What is the difference in the square root graph and the log graph? It crosses the x-axis, okay? Our square root's not going to cross, okay? However, the log does. Does it look anything like an exponential? No, okay? Exponential's got this little tail on it, okay? So, if we go back here, what is the only one it could be? It is a square root. So, on your paper, I want you to circle number 3, the function which is a square root. It's also a square root because what's this topic called? Square root functions and equations. Okay? Alright. Oh, that was number 3. Whoops. Alright, next is transformations. We did transformation rules in topic 3 quite some time ago. Okay? So, let's see. Let's go to number 2. It says, on page 295, it says, what approximate values of a, h, and k are in the general square root function of y equals a, the square root of x minus h plus k? How many of you remember that parent function? Nice. You're killing it. I'm talking straight up killing it. Let's see. I want to go there. No. Okay. A values. What do A values do? They either make the graph go... What are they doing? Wider or more narrow. So, out beside where it said A equals, we're going to find the values too, but I want you to write... wider or more narrow. Also called a vertical stretch or compression. Now, what does H equal? What kind of shift? Left or right. So we got a horizontal shift. You can remember that because horizontal starts with the letter H, and you're looking for your H value. Remember, horizontal shifts are the opposite of what your brain thinks. What about a K? What kind of shift is that? It is a vertical shift. All right. Let's see. Right here, we have our little yellow dotted lines. Everybody see the yellow dots? Okay, what kind of function is that forming? I connected those. What kind of function is that? A square root, okay? Now, I'm trying to get, oh, y'all can't see that, that's hard. I am trying to get this red line on my yellow line, okay? So, I'm going to start by moving this A value. Does A value need to be greater than 1? Or should it be less than 1? Or should it be between 0 and 1? It don't need to be negative, because can you even see the negative part? Nope. If it is greater than 1, it's straight up. Won't need that. So we've got to match the red. So that looks pretty accurate, right? All right. This thing says to keep going. Those are the correct values for... Oh, there it is. Okay. What is the only value that changed? A. Okay. So, on your paper, out where you wrote the definitions of A, H, and K, I want you to write A equals 0.20. Did H change? Nope, so it's just 0. And our K is also just 0. Okay? All right, now let's see if you remember your transformation rules. Okay. Number 3. In general, how does the parameter A affect the graph of y equals A times the square root of x? Well, here's our A, okay? Our two options, go ahead and write this. Our two options are A is greater than 1, or A is between 0 and 1. Number 3 on the next page, 296. We're writing the rules. All right, so if A is greater than 1, it is stretched vertically. If it is between 0 and 1, it is compressed vertically. These are the same rules that we did in topic 3. Nothing changes. So, A value, when it is greater than 1, it's vertically stretched. Okay? When it is between 0 and 1, what is that graph doing? It's becoming what? From here to here, the graph is, what's it doing?
Compressing.
It is compressing, but the graph is becoming flat. Okay, so out beside where you wrote compressed vertically, I want you to write the word flat. F-L-A-T, flat. Can these graphs really become more narrow or wider? If I move this up, what's it doing? It's drawing closer to what axis? The y-axis, okay? If I go down, it's landing on what axis? If it's negative, it is reflecting across what axis? The x-axis. So just remember, negative out front always means that it is reflecting. Okay? All right. Let's see. Make sure you have those written on your paper as well. All right. Number 11. Number 11 is a reinforced problem. So it's not on Agile Mind. But it wants us to write 3 different functions. The first one goes to the left 5 and up 1. So, do we have an A value? Does it say A equals anything? Nope, so we don't have an A value. So, we have the square root of x. In order for it to go left 5, what does it have to say under the square root? X plus 5 or x minus 5? X plus 5. If it's going up 1, where's that positive 1 going? On the outside. All right, the second one says it is reflected across the x-axis and down 3. Do I have an A value? I don't have an A value, but what does have to go out front? The negative. So technically my A value would be -1, okay? All right, then I have the square root of x. Does anything need to go with that x? Nope, because I don't have what kind of value? I don't have an h value. And it goes down 3, so that negative 3 needs to be on the outside. Good. All right, and the last one. We are vertically stretched by 3. We are right 2, and we are up 4. So, y equals, what's going to come first? 3. The square root of, good job, Rain, x minus 2. And then on the outside is plus 4. Do those make sense? Yes. Okay. All right. On number 12, you have studied several transformations of the parent square root function. Consider y equals the square root of 16x. Now, I want to break that down to where it looks like y equals a square root of x. Okay? What this means, y equals the square root of 16 times the square root of x. Are these two things the same? Yes or no? Yeah, they're the same. All I did was break it down. Okay? So, these are the same. What's the square root of 16? 4. And can you simplify the square root of x? Nope. So we just have 4 square root of x. Now, are these two on the right in the same form? We have our a value, which is 4, and we have our square root of x. All right. Now, everybody got a calculator? I want you to graph on 2 different lines. Y equals the square root of x. And then on the next line, y equals square root of negative x. Notice the negative is on the inside. All right, so we have the square root of x in the first one. In the second one, you were we have the square root of negative x. Then we're hitting graph. What do you notice happens? It's reflected across which axis? It's reflected across the y-axis. So, what this means, it wants to know how it compares. Well, y equals the square root of negative x is a reflection across the y-axis. What have we been dealing with? Reflection over what axis? They've been flipping across the x. And the negative sign has been on the outside. But if we want to flip across the y, the negative has to be on the inside. So, if you have room at the bottom, I want you to make a little note and say negative on inside equals reflection over y. Negative on outside equals reflection over x. Make you a little note. All right, let's see. On the next page, number 14, 15, 16, 17. Okay. So, here, you have to do simplifying before you get your answers. Okay? So, on the first one, it says, a transformation of the graph is vertically stretched by a factor of 2. Okay. Do you see any answers that have the number 2 in there? No. But what we just did on the problem before, remember this? I'm splitting up my 4 and my x. What's the square root of 4? 2. So would these two things not be the same? Yes? No? Yeah. So, my first one is right here. Now, the next one says it is vertically stretched by a factor of 4. So, what number am I looking to be on the outside? Of 4. So, the only one it can be is this right here. All right. The next one says it is stretched by a factor of 3. Do you see any 3s up there, though? But what do you know the square root of 9 is? Square root of 9 is 3, okay? And it's reflected across the x-axis. What did we just write in our little note? The negative has to be where for the x-axis? On the outside. So the only one it can be is right here. Which is the same thing as me saying y equals negative square root of 9 times the square root of x when I simplify the square root of 9, I get the number 3. Okay? On the last one, the only thing that's different is it says it is reflected across the y-axis. Where does the negative go for a y-axis reflection? On the inside. So, the only answer I could have would be this one. Questions? Make sense? All right. Let's see. We're going to solve some some square root. So let's jump all the way over to page 310 in our workbook. I'm just going to go to this. All right, so this is what you'll be doing tomorrow. Your worksheet is solving square roots, okay? So, on the first one, we have the square root of x minus 3 minus x equals -5. All right, so first, let's see. I want to move something. I want to get my square root by itself. So if I want to get my square root by itself, what should I move? My x. So to get rid of a negative x, I'm going to do what to the other side? I'm going to add it. So go ahead and add your x. Now this is just an Ellery thing, but I'm going to change this right here to where it reads x minus 5. Now you don't have to do that, but I'm just doing that because I don't want to deal with those negatives. Okay? Are these two things the same thing? Yes. My signs are still the same. My x is still positive and my 5 is still negative. So if you want to change, you can. If not, no big deal. It's going to work out the same way. Okay? So now I have to get rid of a square root. In order to get rid of a square root, I have to do what? I have to square it because the opposite of square rooting is squaring. Okay? Am I going to square one side or both sides? I'm going to square both, okay? On the left side, what happens to the square root and the square? They just what? If they're opposites, they're just... What are they doing? They're just canceling out, okay? So I'm left with x minus 3 equals, how many x minus 5s do I have now? I have 2. So I'm going to go over here to the right. I'm going to FOIL x minus 5 and x minus 5. X times x is x squared. X times -5 is a -5 times -5 makes a positive 25. What do I do to everything inside my box? I have to combine what? I have to combine like terms. So we still have x minus 3 on the left. We have an x squared, but how many x's do I have? I have a -5 and a -5. If I add those, I have -10 plus 25. Everybody agree? All right. I want to move everything to the right. What should I do with the x minus 3? What am I going to do with that x? Am I going to add the x or am I going to subtract the x? I'm going to subtract the x. And what am I going to do to the 3? I'm going to add the 3. So I have minus x plus 3. X squared minus 11x plus 28. What kind of function is this? A quadratic. So I can use the big X that you are all pro at. Dallas, what goes in the bottom of my X? My B value, my middle term. What is it? -11. BG, what goes in the top? 28. A times C. What two numbers add to get -11 and they multiply to get positive 28? -7 and -4. Now, what's my A value? 1. So I'm supposed to divide my factors by my A value. But if I divide them by 1, does anything change? Nope. So I have two factors. X minus 7 and x minus 4. But those are not my solutions. Those are just my factors. How do I find my solutions from my factors? What do I do to those factors? I set them equal to 0. So I'm going to have to erase this. So I'm going to set both of them equal to 0. So I have x minus 7 equals 0 and x minus 4 equals 0. Basically, what's it doing? It's just changing the sign. So we have a plus 7 and a plus 4. So x equals 7 and x equals 4. Now last week, we talked about some kind of solution that don't always work. What was that word called? Extraneous. Okay? So now, guess what you have to do with your two solutions? You gotta plug them back in. Okay? So, for the first one, I'm going to plug in 7 first. So I have the square root of x minus 3 minus x equals a -5. So every time I see the x, I'm plugging it in. But what am I using to plug it in? I am using 7, but what do I need to put around that 7? I always got to use parentheses. Good job. All right, so I have 7 minus 3 minus 7 more is a -5. If I simplify that, what's 7 minus 3? 4 minus 7, -5. What's the square root of 4? All right, so I got 2 minus 7 equals negative 5. What's 2 minus 7? Does negative 5 equal negative 5? Yes. So is 7 a solution? Yes, 7 is a solution. So I put your little check mark under 7. Now we got to check 4. So we got a 4 here and a 4 here. What's 4 minus 3? 1. What's the square root of 1? Just 1. Just 1. So I have 1 minus 4. Does 1 minus 4, what does that make? Negative 3. Does negative 3 equal negative 5? So which one is my only solution? 7. Good job. All right. B. Let's see, that one's silly. All right. B's a little bit, I don't know if I would say challenging, but different. X minus 3 plus the square root of x plus 2 equals 5. Alright, so your goal when you are dealing with square roots is you want to get one square root by itself. Okay? So, let's go ahead and move. The square root of x plus 2. Alright, how do I get rid of a square root? A square. So, I'm left with x minus 3 equals 5 minus the square root of x plus 2. So I want to get rid of my square root on the left. Do I square one side or do I square both sides? Both sides. A square and a square root, they cancel. So I've got, x minus 3 equals, hold on, let me, why can I not cancel out oh, my pen's dead. This right here. Is it all by itself? What does it have attached? It's got a 5 attached, okay? So we can't cross those out because that parentheses is going to what? is that square just going to the 5? Or is it just going to the x plus 2? No, it's going to everything, okay? So we cannot cross those out. So we are still left with 5 minus the square root of x plus 2, and all of that's squared. All right, so over here on the right, I've got, how many of these do I have? How many 5 minus the square root of x plus 2's do I have? I got 2 of them. So, let me erase this. Okay, it's going to be a little sloppy because my pen's dead, so I'm using my finger. All right, 5 minus the square root of x plus 2. And 5 minus the square root of x plus 2. All right, the first block is the easiest one. What's 5 times 5? 25. All right, now all I'm doing is I'm squishing everything else together. So I have a negative 5 times the square root of x plus 2. And I have a negative 5 times the square root of x plus 2. I can't multiply that 5 and that 2 because they ain't alike. One's under the square root and one's not. So all I'm doing is squishing those together. Okay? Now, what is the square root or the negative square root of x plus 2 times negative square root x plus 2? Let me show it to you in just numbers. If I said negative square root of 4 times negative square root of 4. What's the square root of 4? 2. Keep my negative. What's the square root of 4? Negative 2. And a negative 2 is a... So I'm getting what I started with. Make sense? All right, so if I'm multiplying negative square root of x plus 2 times negative square root of x plus 2, my answer is just going to be what? 2 negatives make a positive, so my answer is just going to be x plus 2. This goes for any square root function. If you multiply 2 like that, it's always going to be what's under. Okay? All right, so x minus 3 equals 5. Not 5. 25 minus 10 square root of x plus 2 plus x plus 2. Where'd that negative 10 come from? Negative 5, negative 5. All right. Now, everybody have this written. I'm going to have to erase it. Yeah? Okay. I guess I could have just got a whole new page. All right, so we had x minus 3 equals 25 minus 10 square root of x plus 2 plus x plus 2, right? Yeah. All right, I want to move everything. I don't want to move everything. But I do want to move what's x minus x? X minus x is just what? X minus x is just 0. Alright. So now I have negative 3 minus 2 is a negative 5. Equals 25 times, not times, minus 10 square root of x plus 2. Now, my goal here is to get that x by itself. So what number am I going to need to move to the left? And you can't move the 10 because the 10 is attached to the square root. We're going to move 25. So, minus 25, negative 5, minus 25 is a negative. Okay, we got negative 30 equals negative 10, the square root of x plus 2. Okay, we're almost done. I want to get x by itself. Okay? I got to get rid of that negative 10 though. So what is negative 10 and that x plus 2 under the square root? What are they doing? Are they adding, subtracting, multiplying, or dividing? They're multiplying. What's the opposite of multiplying? Dividing. So can I not divide both sides by negative 10 to cross those out? Yes. All right, now, negative 30 divided by negative 10 leaves me with a positive 3 equals the square root of x plus 2. How do I get rid of a square root? A square.
Teachers, just a reminder, if you will, come by the office on your planning to do the insurance, if you have insurance with the school. Thank you.
All right, I squared my 3, and I'm left with x plus 2. So 3 squared is 9 equals x plus 2. How do I get x by itself? I subtract what? Subtract 2. 9 minus 2 is 7. So 7 equals x. Now, last thing, what do we have to do with 7 to make sure it works? We plug it back in. So, 7 minus 3 plus the square root of 7 plus 2 equals 5. What's the square root of 7 minus 3? The square root of 4 plus the square root of 9. The square root of 4 is, square root of 9 is, does that equal 5? Yes, so that works. Okay? So, what you're doing tomorrow, that worksheet, and the other 3 problems on number 6. In your workbook. 311. 6, A, B, and C, and those 10 problems. So you only got 13 problems to do. I say that like it's
easy.
You ain't got nothing to do. Some of them aren't too bad. Bell's fixing her.
Well, man, I just lost an hour when I walked in here because I looked up at that clock and I was like, what the?
Oh, I didn't.
I've just been real busy. I knew this class was fixing to let out. I gotta be back. I gotta leave that.
Oh, that's right. That's right. That's right.
I'll be back in a minute.
Okay. I need to change that. Yeah. I forgot. Bye, guys. Don't forget to do your work and bring it back on Wednesday. Okay?
We don't have to do Agile Mind for this, right?
No Agile Mind. Thank you.
Oh yeah. On my test, I changed some answers. I wrote them on